All right, so today we're going to apply the Pythagorean theorem, which we've been working with all week, to practical problems. So if we take a look at, since the Masters was last weekend, we take a look at this picture of a hole from a golf course. We notice that if we drive the ball straight and get to the edge of the fairway here, it'll be 120 yards, which will leave us with 50 yards to get to the flag. Or if we were really good at golf, this is a very short par 5, by the way. If you were really good at golf, you might be able to go straight for the flag, but you would need to know how far that is. Well, and we can use our Pythagorean theorem by drawing our angle here, knowing that this is going to be our C, and we do not know what the hypotenuse is. And we can use our Pythagorean theorem to solve for that. All right. So good news is with a lot of these, they'll give you the picture. I believe on the test, every one of them gives you the picture. So you don't have to worry so much about drawing the picture or even labeling parts. It's mostly just using the Pythagorean theorem. All right, so Mark's on his way home from work, drives 35 miles due north and then 42 miles due west. Find the shortest distance he can cover to reach home early, excuse me. All right, so he's going to drive due north first. Oops. Due north. And then he's going to drive due west. So we want to find the shortest distance. Well, for us, that's going to be right here. All right, and this is where you use some logic, some critical thinking, right? And we can kind of assume that our right angle is going to be here, which means that this is going to be our hypotenuse. All right, so we do not know what C equals. Well, but we do know that our legs, A and B, are going to be 35 and 42. So we have A squared plus B squared equals C squared. So the only thing new today is just really being able to read a problem and make sure we can make it out with the picture. All right, so we're going to have this 32 squared. Again, don't forget about that. Our square. Our exponent 42 is going to be our B. Don't forget about our square. And then we don't know what C squared is. Now you could do this the Desmos route, which we will do here in a few. Or you can do it by hand. So 35 squared is 1,225. 42 squared is 1,764. And again, we don't know what C is. When we add our numbers together, we get 2,989, and that equals C squared. And when we take the square root, we get, I'm going to go ahead and round to the 10th. We'll get 54.67, blah, blah, blah. But because I'm rounding to the 10th, I look to the right. Because this number is 5 or greater, I had 1. Right? Make sure we didn't lose that skill. And that'll be C squared. And this will be miles. So I forgot we got to take the square root of both sides. Right? That's going to cancel out. And we'll be left with just C. All right, sorry about that. When you guys do this enough, it'll just kind of become routine and you won't even have to think about the steps. I will not let that happen again. So an anchor line for a tower needs to be replaced. The tower is 96 feet tall. The anchor line is 105 feet long. How far from the tower can it be placed to the nearest foot? Again, here it looks like we can probably draw a right angle here, which means that our C, or our hypotenuse, is going to equal 105 feet. Well, I like to say that we're always looking for our A, and then our B is just another number. All right, same thing, A squared plus B squared equals C squared. Notice here we're actually looking for a leg, not the hypotenuse. So I can put in my 105 for C squared, or 105 for C, and then don't make sure you square it. Or I know my B is 96, for each square, and then A squared. All right, so for these, again, Desmos is probably helpful with some of these bigger numbers. But just to show you by hand, 96 squared is 9,216, and 105 squared is going to be 11,025. All right, don't forget we want to get that a squared by itself. So we're going to do that by subtracting 9,216 from both sides. And we'll be left with a squared equals 1,809. Notice in this problem, we're going to round to the nearest whole foot, or the nearest whole number, essentially. Don't forget to take the square root of both sides, because that'll get rid of your square. You get a by itself, and that's going to equal 42.5323, blah, 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 blah. Well, we're rounding to the nearest foot. So I look to my right, that's a 5 or higher. So I know I need to add 1. So I get 43 feet. And that's how far away from the base of our tower we need to set this anchor line. All right, let's do one with Desmos here. Joshua won a laptop in a school raffle. The laptop screen measures 10 inches in height and 24 inches in width. Find the diagonal length of the laptop screen. When you see this diagonal, it's kind of like a red flag that you're going to be looking for the hypotenuse. And when you look at your picture, it pretty much makes that obvious. So let's see if I have Desmos open. Oh, it's not good today with making sure that I have Desmos readily available. All righty. Come on. There we go. All right, so let's go to our formula. We're looking for a hypotenuse. So we're going to use this formula, C equals square root of a squared plus b squared. So I'm going to go ahead and pop that in Desmos. C equals, can you do square? Nice. A squared plus b squared, b squared. Enter a equals, b equals, and I like to put c equals, even though we're not going to put a value in for c, we know that's what we're looking for. So it kind of gives us like an immediate answer, right? So let's come back to our problem. We know we're looking for c. I'm going to make a my smallest. You don't have to. That's just something that I like to do. I figure the more structured it is, the less mistakes there are. Come over here to Desmos. Type in my a, which is 10, my b, which is 24. And you'll see that it gives me my answer at the top. But it also, where I didn't put a value in for c, it gives me that same answer. So this is kind of helpful as well, because we're looking, when we're verifying, we're looking for the two numbers to match. So when you see two numbers that match, here you also have an answer. So we will have 20 equals 26 inches. All right. Let's see, Joey made a sandwich. It's 4 inches long and 6 inches high. If he cuts the sandwich in half, as shown in the figure, what would be the diagonal length of the sandwich? Again, this word diagonal kind of screams we're looking for the hypotenuse. And when you look at the picture, it's pretty obvious. And this is all assuming that this is, in fact, a right triangle. Now, remember, good Desmos practice is to delete everything and write your formula in from scratch. I will not be doing that just to save some time. But for you guys, don't ask me what the formula is on the test. All right, so I put a 4 in for 8, a 6 in for B, and you'll see that I get my C value here, which is going to be 7.211, right? So C equals 7.211, whatever. Well, let's just say I wanted to round to the nearest inch. I would look to the right. Is this number 5 or greater? No. So I can just call it at 7. Nothing has to change. So the diagonal, or the hypotenuse, corner to corner of our sandwich, is 7 inches. All right, a 15-foot tree casts a shadow that is 8 feet long. What is the distance from the tip of the tree to the tip of the shadow? So if you really think, logically, use some common sense, you would kind of realize, think about like if you're a bird, if you're at the top of the tree and you're looking where the shadow casts, you're looking at an angle, right? So there's all these lines don't really match up, but here's our right angle. So we're definitely looking for the hypotenuse. And if I come into Desmos, let me go ahead and label this A, my smallest number, B, my middle number. And because I'm looking for my hypotenuse, when I plug in my A and my B with my formula, I get my C to equal an exact 17 feet. All right, that's just straight up with Desmos. Again, just to point this out, in Desmos, notice I didn't put a value in for C. It computes one for me. So that's the same as us doing it by hand, just the calculator does the work. All right, and last but not least, Rachel bought a rug for her apartment. The rug is 11 feet long and 9 feet wide. Find the diagonal length of the rug, diagonal. So you guys will probably notice that this looks a little tricky, right? Like you're like, hold on, but if I draw my angle here, what am I pointing to? So you can either bring this 9 feet over here for this side, right? Because this will be 9 feet. Or you can bring this 11 feet to this side, because we know it's going to be a rectangle. And this will be 11 feet. Oops, forgot the T there. All right, and then from there, you could draw a right angle right here in this corner to the hypotenuse, which would be C, which we don't know. So our A would be 9 feet, and our B would be 11. And again, with Desmos, it just makes it so easy. You just pop in a 9, pop in an 11, and you'll see that we get 14.212. Right, so C is going to be 14.212, but I don't care. All right, so if I want to round to the nearest foot, I look to my right. Is this number 5 or greater? No, so I can just get rid of all of it. And C, the diagonal of our rug, will be 14 feet. That's pretty much it for the Pythagorean theorem. If you guys have any questions, feel free to reach out. Other than that, have a wonderful rest of the day and weekend.